Welcome to Hexagon Tutorials Dart series. In this video, we'll explore abstract classes and interfaces in Dart, understanding their role in creating structured and reusable code. An abstract class serves as a blueprint for other classes. It provides a structured foundation, ensuring that certain functionalities are implemented by its subclass. Unlike regular classes, an abstract class cannot be instantiated directly. This means you cannot create an object from it. Instead, it acts as a base class that other classes must extend and build upon. Now, let's look at some key features of abstract classes. First, an abstract class is declared using the abstract keyword. This tells Dart that the class is incomplete and must be extended by another class before it can be used. Second, an abstract class can contain both abstract methods and concrete methods. Abstract methods are declared without a body. This means they don't have an implementation in the abstract class itself and must be overridden in the subclass. Concrete methods, on the other hand, are fully implemented methods that subclass can inherit and use without modification. Finally, abstract classes promote code reusability and structure. They allow developers to define a common interface for multiple subclasses while still permitting each subclass to implement specific behaviors in its own way. Why should we use abstract classes? First, abstract classes enforce a contract. They ensure that all subclasses implement essential methods, maintaining consistency in design. This is especially useful when working in large teams where uniformity is key. Second, they improve maintainability. By defining shared behaviors in one place, abstract classes keep the code organized and structured. Instead of rewriting the same methods in multiple classes, you can define them once in the abstract class and reuse them in all subclasses. Third, abstract classes support partial implementation. This means you can provide predefined functionality for some methods while leaving others as abstract, requiring subclass to provide their own unique implementations. This balance of flexibility and structure makes your code more scalable and easier to manage. Abstract classes are particularly useful in large applications where multiple related classes need to share common behaviors while still allowing customization for specific needs. They provide a strong foundation for building a well-structured and flexible codebase. An abstract method is a method declared inside an abstract class without a body. It acts as a placeholder that must be overridden by any subclass that extends the abstract class. Since it has no implementation, it enforces a contract, ensuring that all subclasses provide their own version of the method. On the other hand, a concrete method is a fully implemented method inside an abstract class. Unlike an abstract method, it has a body and provides a specific functionality that can be inherited and used directly by subclass without modification. By using abstract methods, we ensure that subclass define their own unique behaviors, while concrete methods allow code reuse, improving maintainability and reducing redundancy. This code is a perfect example of how abstract classes and abstract methods work in Dart. The shape class is declared as abstract, meaning it serves as a blueprint for other classes but cannot be instantiated directly it contains. An abstract method draw, which has no body. This method must be overridden by any subclass that extends shape a concrete method displayInfo, which has a body and provides a common implementation that can be used directly by subclass. The circle and rectangle classes inherit from shape and provide their own custom implementation of the draw method using method overriding. In the main function, we create instances of circle and rectangle. Each object calls draw, which executes its overridden version of the method. Both objects, also called displayInfo, which runs the inherited method from the shape class. Key takeaways: abstract classes define a common structure for multiple subclass. Abstract methods must be overridden in the subclass. Concrete methods provide shared functionality. Reducing code duplication. Polymorphism allows us to treat different shapes uniformly while enabling each to have unique behavior. This approach ensures code consistency, reusability, and flexibility, making it easier to manage complex applications with multiple related classes. In Dart, an interface defines a contract, a set of methods that any class must implement if it chooses to follow the interface. This approach helps achieve abstraction, enforce specific behaviors, and promote code reusability in your application. Implementing an interface in Dart. To implement an interface in Dart, we use the implements keyword. When a class implements an interface, it must override all methods defined in that interface. This ensures that every implementing class provides its own custom logic while still following the defined structure. Unlike inheritance, where a subclass can inherit method implementations from a parent class, implementing an interface only enforces the structure, requiring the class to define its own implementations for each method. By using interfaces, you can design flexible, scalable, and modular applications, ensuring a clear and consistent code structure. Interfaces in Dart provide several important benefits that help in writing structured and efficient code. The first benefit is consistency. Interfaces ensure that multiple classes follow a common structure. This means that any class implementing an interface must include all the required methods, making the code more organized and predictable. The second benefit is flexibility. In Dart, a class can implement multiple interfaces, unlike inheritance, where a class can extend only one parent class. This allows different behaviors to be combined in a single class, improving code organization and making it easier to adapt to different requirements. The third benefit is code reusability. Interfaces promote a modular approach to development, making the code easier to maintain and extend. When a project grows, having well-defined interfaces helps in updating or modifying functionality without affecting other parts of the code. By using interfaces, a structured yet flexible architecture is achieved, ensuring that the code remains scalable and easy to manage. In this example, printable is an interface that defines a printer-tails method but doesn't provide any implementation. The book and magazine classes implement this interface, meaning they must provide their own version of printer-tails. Unlike abstract classes, interfaces only declare methods, ensuring that each class implements them in its own way. This makes the code more flexible and reusable. By using polymorphism, we can store both book and magazine objects in a printable reference. This allows different types of objects to be handled in a uniform way, making the code more organized and easier to expand in the future. In this code, we are demonstrating the concept of multiple interfaces using the readable and writable interfaces. The readable interface has a read method and the writable interface has a write method. Both methods are declared but not implemented. The document class implements both readable and writable, meaning it must provide its own implementation for the read and write methods. This allows document to inherit behaviors from multiple sources, making it more versatile. In the main function, we create an instance of document and call both methods. This shows how a single class can inherit and implement multiple behaviors using interfaces, ensuring flexibility and better code organization. Let's see a real-world example of how interfaces and polymorphism work in a payment system. Here, we have an abstract class payment that acts as a blueprint. It defines a method process payment, but it doesn't provide any implementation. This ensures that any class implementing payment must define its own way of processing payments. The credit card payment and PayPal payment classes implement the payment interface and provide their own logic. When a credit card payment is processed, it prints processing via credit card, and when PayPal is used, it prints processing via PayPal. In the main function, we store different payment methods in a list of payment objects and use a loop to call process payment. Thanks to polymorphism, the correct method is executed based on the actual object type at runtime. This approach makes the code flexible and scalable. New payment methods like Bitcoin or UPI can be added just by implementing payment without changing existing logic. This is the true power of interfaces and polymorphism in object-oriented programming. Let's break down the key differences between abstract classes and interfaces in Dart. First, keyword usage. An abstract class is declared using the abstract keyword, while an interface is implemented using the implements keyword. Next, instantiation. Neither abstract classes nor interfaces can be instantiated directly. Instead, they must be extended or implemented by another class. Now, let's talk about methods. Abstract classes can have both abstract methods, which don't have a body, and concrete methods, which are fully implemented. On the other hand, interfaces can only contain method declarations, meaning all methods must be overridden in the implementing class. Moving on to multiple inheritance. Abstract classes only support single inheritance, meaning a class can extend only one abstract class. However, interfaces support multiple implementations, allowing a class to implement multiple interfaces at once. Finally, the use case. Use abstract classes when you want to provide a common base with shared logic while ensuring certain methods are implemented in subclass. Use interfaces when you want to define a structure or contract that multiple unrelated classes must follow without enforcing shared functionality. In summary, abstract classes help in code reusability with some predefined behavior, while interfaces help in defining a set of rules that classes must adhere to. Understanding the difference between the two is essential for designing efficient and scalable applications. Thanks for watching the video. Do like, share, and subscribe to our channel.